Okay, folks, hopefully I make each one of these problems clear. Um, the test isn't going to be these exact problems, but they'll be similar to them. And in some situations, it might be a slight variation, and you might disagree with me. You might feel like, man, it doesn't feel that similar. And I'll try to make it clear. I can't guarantee they're going to look exactly like this. The other thing is, I'm not going to let you use this practice test on the actual test. So we've got to make a little page of notes or a note card or study from it enough to where we don't need any notes. But you could have a little note card, like a 3x5 card, that'd be fine. All right. So this first one is the idea of a composite function. If these two are inverses of each other, this idea has a little bit more meaning in this chapter. But, composite functions are important. There's a lot of composite functions. I don't like this kind of notation. So the first thing I do is I write it like this, because we all know what to do with parentheses. You do whatever's inside the furthest parenthesis first. Well, there's nothing to do with just a -2. It's just -2. But what does this mean? Well, I'm going to do f of -2. That means plug -2 into the f function. So I put it right there. So I get the square root of -2 plus 2. I like that because that's 0. So the square root of 0 is 0, right? But wait. I'm not just doing that. I got to still do the g of, that was the f of function. So now I'm doing the g function. So I need to do g of 0. So that means I put 0 into the g function. So I go 2 times 0 squared plus 1. That answer should be 1. Okay, let's go to the next one. Number 6, same idea here. We're doing f following g. So when you hear that following g, that means g is done first, then the f function's done. But if you write it like this, it's a little bit clearer. And you notice like there's no number here like we had on the last one. What was the last one? We plugged in -2, I think, right? We plugged in -2 for that x value right there. Well, since there's no number on this one, we're trying to algebraically find what would the function be. So what that means is you go f of, and then you replace g of x with what it's equal to. That's 1 over x, right? So if I put a 1 over x in here, that means I'm going to take 1 over x and I'm going to put it into the f function wherever I see x. So I'm going to get 1 over x plus 1 all divided by 1 over x minus 1. See, what I did was I looked at my f function. I said, hey, there's an x right there. There's an x right there. So I'm going to replace those x's with the 1 over x. Okay. Man, I hope I'm making that clear. So we're replacing the x with 1 over x in each one of those spots. Now, this is the right answer. It can probably be simplified a little bit. So when you check the answer in the back of the book, it might not look exactly like this. What they're probably going to do is they're going to get a common denominator between these two. So we get 1 over x plus x over x. X over x is the same thing as 1, right? And then I get 1 over x minus x over x. And that gives me 1 plus x divided by x in the numerator. And we get 1 minus x divided by x in the denominator. When you take a fraction divided by another fraction, you change that into multiplication like this. Multiply by the reciprocal of the denominator. So I get x over 1 minus x. And these guys are going to divide out to 1. So I'm down to 1 plus x all over 1 minus x. It's really close to this one, but a little different on the sign in the denominator. So be real careful. Don't try to make conclusions, I would say, based on what you see on a few of these on, all future composite functions. Okay, so just follow the process. This would get you a 6 out of 6. This is probably going to get you a 5 out of 6. Haven't decided yet how I'll grade that, but you totally know what you're doing. It just doesn't look very simplified. Number 10, okay, it says find the inverse. So this is where you switch the x and the y. Step 1 is switch x and y, right? Switch x and y. And so let's do that. I go x equals 1 over y minus 1, okay? Step 2, solve for y. Well, look, y minus 1's in the denominator. X is up here. It's like x over 1. You can think about it like that. And I can switch the locations of these two in a proportion and still the equivalent proportion to what we had before. So I could put like y over 1 is equal to 1 over x. So I just switch the location of where the x and the y minus 1 are. And then I just move this 1 right here to the other side because this divide by 1 doesn't really mean anything, right? So I've really got just y minus 1 is like equal to 1 over x. And then if I add 1 to both sides, right? So I'm now down to 1 over x plus 1. Okay. If you look in the back of the book, they might try to combine these two together like we did on the previous problem. They might put down something like this, 1 plus x all over x. So I would not probably count this as a 6 over this because you totally get what you're doing. Now, it does say, what does f of f inverse equal? Okay, so here we go. We're going to try that. F of f inverse of x. Okay. So if I go and I replace f inverse right here with what it is, 1 plus x over x, 1 plus x all over x. Okay. Now I'm going to replace wherever I see an x in here with what the f function is. So I get 1 plus 1 over x minus 1 all over. Ooh, this is a little tricky, isn't it? So I replaced wherever I saw that x with 1 plus x over x, didn't I? Wait. Oh, man. Hold on one second. Wherever I see an x, sorry, I'm going to replace it with 1 over x minus 1, right? Because I'm now putting, holy moly. Let me slow down here for a second. Let me back up for just a second. So I put this, I think, the wrong way, right? So wherever I see x in the f function, I want to replace it with this guy right here. So my bad. Got lost track of what I was doing. So wherever I see an x in the f function, I'm going to replace it with 1 plus x all over x. Okay, there we go. Now let's see here. I want to simplify all this, and it should come out to be an x, a plain old x. So I need an x over x right here, and then I could combine them together. So I get 1 over, let's see here, 1 plus x all over x minus x over x. Notice now they have a common denominator, so I can add their numerators together. And x minus x is going to give me no x's, right? I got 0 there. So now I'm down to 1 over x, which is the equivalent to x. Boom. See, this shows that my inverse is actually correct, check mark, because when I do the function following the inverse function, it takes me right back to where we started. We started at an x, boom, we ended up back at an x. So that means really these two functions kind of undo each other, all right? So this is like a proof that we have the right answer. It's a proof that we have the correct inverse function. So f inverse. Now, technically, we're supposed to do it the other way as well. We're supposed to go f inverse following f. But I just want you to show one of these. It'd take, I think, a little bit too long to do both of them. All right. Anyways, let's go on. Number 14, change the exponential function into an equivalent log function. So let's see, the base is 5. So I go log base 5. The exponent is a 2, so that's going to go on the other side of the equation because this is where the exponent goes. And the number we get, I know it's a variable, but that goes right here because what do you have to raise 5 to? Well, we're raising it to the second power to get z, right? That's number 14. Number 16. I'm going to do this one and the rest in video 2. So I'm going to pause right there, and then I'll come back to this in video 2.